Good morning guys and welcome to Mind Your Math. So today we are down to the last chapter, the last lesson on circles chapter. It has been a pretty lengthy chapter. I have already told you I guess in one of the videos, and so many theorems and so many concepts. So thankfully we are at the end of the chapter. We are going to learn two more concepts. One is the concept of concyclic points and the second one, very important one, cyclic quadrilaterals. So many questions are being asked from this particular concept. So keep practicing, do the sums from NCERT for sure, from the reference book preferably, and previous year's question papers or worksheets that the teachers give you, please go through them, because then you will know the difficulty level of the questions that they might be setting for the examination. And any doubts, mail me at the mail ID given below in the description box. Okay. Concyclic points. So let us first now, what is the definition of concyclic points? Concyclic points are points that lie on the same circle. Now, we have learned two words I mentioned in the last video. One was collinear and non-collinear. When did we discuss that? We discussed that when we were discussing about how many points are required to draw a circle. We also learned about concentric circles, circles having the same center but different radii. But did we learn that? We learned that when we were doing a sum on concentric circles, which was something like this, we needed to prove some length was equal, something like that. Now we are going to learn about concyclic points. Now, okay, we have a circle. I have not marked the center. We have a chord AB. Now, what can you say about this angle and this angle? Both these angles have to be equal because they are angles in the same segment of the circle. Okay. Now, if I were to eliminate the circle is not there. You have a chord and you have two angles over here. So basically you have got 4 points, P, Q, A and B. Okay. We just showed that these 4 points lie on a circle. Basically, we have got 4 points lying on a plane. Now, these 4 points lying on a plane satisfies a condition like this. I can say that these 4 points can fit into the circumference of a circle. These 4 points, therefore, I will call them as concyclic points. Okay, that is the basic definition of concyclic points. 4 points that lie on the same circle, they are concyclic points, as I told you. Now, we will do a proper proof of why these 4 points will be called as concyclic points. This I have given you a rough idea about how this thing works and how you have to identify concyclic points. Now we will do a proper mathematical proof on why it has to be concyclic and why they should definitely lie on a circle. Okay, you have a circle with a chord AB. It is given that angle APB is equal to angle AQB. So basically our idea is this is a chord AB and angles in the same segment or basically on the same side of the chord. These two angles are given to be equal. Okay. We need to prove that A, P, B and Q are concyclic points. Fine. Now I have drawn the diagram. This is our circle and this is our point P. So now you know that in order to draw a circle, we need at least a minimum or at least 3 non-collinear points. So I am taking A, B and P as 3 non-collinear points through which I will be drawing a circle. Okay, and I am joining A and B by a chord. Here I have got APB. Now, according to what I need to prove that the point Q is also on this particular circle under the condition that angle AQB is also equal to angle APB. Okay. Now, I am assuming that angle Q is not on the circle. So, the angle Q has to be either inside the circle or outside the circle. So, here, either here or here. Okay. And since this is on the same line, the point at which it is intersecting the circle, I am going to name as Q dash. Okay. You know that according to the statement, angle AQB and angle APB are equal. Okay. So, if this is theta, this is also theta. Fine. Now, Q dash is a point that is intersecting the circle. So, according to the theorem, angle APB and angle AQ dash P also has to be equal because they are angles in the same segment. So, this is also equal to theta. Okay. Now, if you look at the triangle BQQ dash, if you look at this particular triangle, you can see that this angle is the exterior angle for this triangle. And you know, exterior angle is equal to the sum of the opposite interior angles. But in this case, we are getting the exterior angle is equal to the one of the interior angles, which is not possible. So Q and Q dash has to be the same point. So Q also lies on the circle. The same logic applies for the point which is outside the circle also. So all these 4 points have to be concyclic if they have the same angles on the same side of the chord. Okay. Now we have done the proof. Now let me state the theorem. Our theorem states that if a line segment joining 2 points. So if a line segment joining 2 points subtends equal angles at 2 other points lying on the same side of the line segment, then these 4 points are concyclic or they lie on a circle. Okay, I'll repeat again. If a line segment joining 2 points subtend equal angles at 2 other points on the same side of the line segment, then those 4 points are concyclic. I have not seen many sums based on this particular concept, but always remember that if you have a question wherein you need to prove 4 points lie on the same circle and they are giving you this angle, you can use theorem, or if there is some way that you can find out these 2 angles, manipulate and then use this particular theorem in order to show that these 4 points lie on a circle. Okay, we are down to the last concept of this particular chapter, which is cyclic quadrilateral. So first we go through the definition of what is cyclic quadrilateral and what are the theorems based on cyclic quadrilaterals. So what is a cyclic quadrilateral? A cyclic quadrilateral is a 4-sided figure whose vertices lie on a circle. Okay, all the 4 vertices have to touch the circumference of the circle. Okay, such a quadrilateral is called as a cyclic quadrilateral. The first theorem, the opposite angles of a cyclic quadrilateral are supplementary. So A, B, C and D, angle C plus angle A is 180 and angle B plus angle D is also equal to 180. If the sum of the opposite angles of any quadrilateral is equal to 180 degree, then that quadrilateral is a cyclic quadrilateral. That's the converse of the theorem. We need to prove both these theorems. So we will start with the first one. The opposite angles of a cyclic quadrilateral are supplementary. So you are given a cyclic quadrilateral. So ABCD is a quadrilateral which is inside a circle. You need to prove that angle A plus angle C is 180 degree and angle B plus angle D is 180 degree. So I have made a basic construction. I have made 2 triangles using A and C and joining up B and D. Now you know for a fact we cannot use congruence over here because the quadrilateral is a random quadrilateral. The sides are of different length. Okay, so we cannot use congruence over here. So we have to look at some other concept in order to prove this. Okay, so now we have the chord AB and you know that the chord AB subtends 2 angles over here. I know both the angles are equal because of angles in the same segment. So I can say that angle ACB is equal to angle ADB. The reason, angles in the same segment of the circle. Okay, I have a chord BC over here. I know that BC subtends an angle of angle BAC and angle BDC. So I can write angle BAC is equal to angle BDC. Again, angles in the same segment, and I have got 2 statements, 1 and 2. If I am adding both of them, I will have to add LHS and I will have to add RHS. So I will get angle ACB plus angle BAC is equal to angle ADB plus angle BDC. Okay, because I am adding 1 and 2. Now ACB is this angle, BAC is this angle. So in this particular triangle, both the angles are taken care of. The only angle that is pending is angle B. It is an equal statement. If I am adding the same quantity to the LHS and to the RHS, it is not going to make any difference. Okay, so what I will do is that I will add angle B to both the sides. Okay, angle ADB plus angle BDC plus angle B. Okay, now this angle plus this angle plus this angle is equal to 180 degree. because they are the angles of a triangle. So ADB plus BDC will give me the whole of angle D. So I will get here angle D plus angle B is equal to 180. Okay. Now I have got another pair of angles, which is angle A plus angle C. So how will you prove that is also equal to 180? You don't have to go through the same procedure. You just have to say that the angles of a quadrilateral totally measure up to 360 degree, which means that angle A plus angle C plus angle B plus angle D is 360. We already proved this part is 180. So the remaining also has to be 180 degrees. So now we have proved that the opposite angles of a cyclic quadrilateral measure up to 180 degree or they are supplementary. Okay. So in order to do that, I am going to repeat it again. I have taken two triangles by joining the diagonals and I have taken angles in the same segment. See, you have got four chords over here, AB, BC, CD and AD. You can take whichever chord you want and take up the angles that are subtended by the chord in the same segment. Our only condition is that you need to end up with a triangle whose measure will be 180. So we can easily prove. A little bit of manipulation, so you will know exactly which chord to take and which angle to take. Okay, so for me, always I take the one which is the most obvious. So I have taken AB and the BC one. So now we move on to the proof of the converse of the theorem. So what is the converse of the theorem? If any pair of any one pair of a quadrilateral measures 180 degree, then the quadrilateral is a cyclic quadrilateral. So when I say any pair of a quadrilateral is supplementary, the other pair also will be 180 degree. If A plus C is 180 degree, B plus D has to be 180 degree because the sum of the angles of a quadrilateral is 360 degree. So they have told you, so we need to prove that one pair of angles is given to be supplementary. We need to prove that all the four vertices of the quadrilateral lie on a circle. Okay. Now, I am taking angle B plus angle D is equal to 180 degree. Okay. This is given to you. You need to prove that ABCD is cyclic or ABC and D lie on the circumference of a circle. Whatever. Okay. So, now this proof is similar to the previous proof that we have done for concyclic points, where we assume that the points are not concyclic and then we prove that it is concyclic. Okay. Here also we will assume that this is not a cyclic quadrilateral. So we will just assume that this point D is not lying on the circle. So if the point D is not lying on the circle, it has to lie either inside the circle or outside the circle. So if it is lying inside the circle, the point D has to be somewhere here. If it is lying outside the circle, the point D has to be somewhere here. So let this line meet the circle at the point D dash. Okay. Now you know angle B plus angle D is 180 degree. Okay. Now because D dash is a point which is lying on the circle, it becomes a cyclic quadrilateral. ABC D dash becomes a cyclic quadrilateral. So angle B plus angle D dash is equal to 180 degree. Okay, because ABC D dash becomes a cyclic quadrilateral. Now you know that. Check this triangle. The exterior angle is equal to the sum of the opposite interior angles. So this exterior angle has to be equal to the sum of this and this. Correct? But you know that angle B plus D is equal to angle B plus D dash, which means that angle D is equal to angle D dash, which means that our exterior angle is already equal to one of the interior angles, which is not possible. So D and D dash has to be the same point. So ABCD are the vertices of a cyclic quadrilateral. Okay, very easy proof, similar to the proof that we did for the concyclic points. So I think this is very basic proof. Normally they do not ask the converse of the theorem for proof. They normally ask the theorem itself. I think we are good enough to move on to sums. So we will have, pure theoretical sums wherein you have to prove something is like this, something is like that, just like the proof we did right now. Or we will do, and also we will do a few sums wherein you have to find certain angles based on the concept of cyclic quadrilaterals and the remaining theorems that we have gone through. Okay. So let us move on to the sums now. This is our first sum. We need to prove that the quadrilateral formed by the angle bisectors of a cyclic quadrilateral is cyclic. So when we are getting the sum, our first task is to draw the diagram. Once you get the diagram, we at least can hope to figure out something from the diagram. So let us start with the diagram. We have a cyclic quadrilateral. So there is a circle in which there is a quadrilateral. It is said that the angle bisectors of a cyclic quadrilateral also should be cyclic. So if this is the angle bisector of this is the angle bisector of this, it will intersect here. Okay, I am going to name this as ABCD, and I am going to name the vertices, this particular quadrilateral, as P, Q, R and S. We need to prove that this particular quadrilateral is a cyclic quadrilateral. Okay, now in order to prove a particular quadrilateral is cyclic, what do we need to prove? We need to prove that the sum of the opposite angles is 180 degree. So we need to prove either angle P plus angle R is 180 degree or angle Q plus angle S is 180 degree. Because if one pair is 180 degree, the other pair will automatically become 180 degree. So now let us see how we can do that. In order to do that, we need to include those angles in our statements, or whichever proof we are writing, somehow we need to bring that angles into picture. Here we know that AR, BR, CP and DP, all of them are angle bisectors. Okay, so angle A plus angle C is 180 is the fact that we already know, and angle B plus angle D is 180 degree. One more thing we know, this is half of angle B, this is half of angle A. This is half of angle D and this is half of angle C, because they are the angle bisectors. I am trying to include at least one pair of angle of this small cyclic quadrilateral. I have chosen P and R as my angles. Okay, in order to include P and R, I have to take some triangle. I will take ARB. Okay, I will include R over here and I will take CPD. Because the angle that I need, P and R, are present in this particular two triangles. Now I am going to write the statements for these two triangles. Sum of the angles of a triangle is 180 degree. So triangle ARB, I know this angle plus angle R is 180 degree. Now this angle is half angle A, other angle is half angle B, plus our angle R is equal to 180 degree. Okay, or I can say that half of angle A plus angle B plus angle R is 180. Right? Similarly, for triangle CPD, I can write half of angle C plus angle D plus angle P is equal to 180. Okay. Now I am going to add the two statements, because see, keeping the statements like this, I am not able to deduce anything from it. So I will add it. The reason being, when I am adding it, I will get these four angles inside my equation. I know that the sum of all the four angles, angle A plus angle B plus angle C plus angle D, is equal to 360 degree. So okay, now all these angles measure up to 360 degree by 1 by 2, plus angle P plus angle R is equal to 360 degree. Okay, or I can, this is 180, or I can say angle P plus angle R will measure up to 180 degree. 360 minus 180. So I have proved that the quadrilateral from here is a cyclic quadrilateral. An isosceles trapezium is cyclic. We need to prove that. So we know what an isosceles trapezium is. The trapezium wherein its two non-parallel sides are equal. It is called as an isosceles trapezium. I think we did isosceles trapezium when we were doing Heron's formula. Yeah, right. So we did both isosceles and non-isosceles. And so you know what isosceles trapezium is. So if you have an isosceles trapezium, they are asking us to prove that it is always a cyclic. It is always a cyclic trapezium, or it is always cyclic. So we need to prove that, how do you prove a quadrilateral is cyclic? We prove a quadrilateral is cyclic by showing that the sum of the opposite angles is equal to 180 degree. So I need to show that angle A plus angle C is 180 or angle B plus angle D is equal to 180. Okay. Now what is given to us? An isosceles trapezium is given to us, meaning AB is parallel to CD and AD is equal to BC. These are the only facts that we know for the time being. So in order to prove this, we have to start somewhere. We have to make some construction over here. So what we do is that, obviously for isosceles trapezium, the first construction that always comes to our mind is to drop a perpendicular, which is the height. Okay, so I have dropped DE and CF. Now, you know that DE is equal to CF because the distance between the parallel lines at any point will always be the same. So, I know DE is equal to CF. I know this angle is 90 degree, which is angle DEA, and angle CFB is equal to 90 degree by construction. And I also know that AD is equal to BC. It is given to you. So, these two triangles are congruent by RHS congruence. You have a right angle, you have a hypotenuse, and you have another side. So, it is congruent by RHS congruence. So, when two triangles are congruent, by CPCT, we can say that angle A is equal to angle B and this angle is equal to this angle. Fine. Now, you know, when two parallel lines are cut by a transversal, the interior angles are supplementary. So, if this is 90 degree, so these are two parallel lines cut by the transversal DE. So, if this is 90 degree, this also has to be 90 degree. Similarly, this also has to be 90 degree. Fine. Now, what is the sum of angles inside this triangle equal to? So, let us say this angle is theta, this angle is theta. Now, this is 90 degree and this is theta 1. So, this is also theta 1. Okay. So, I can say that theta plus theta 1 plus 90 degree is equal to 180. From this triangle. What is angle B plus angle D equal to? It is theta plus theta 1 plus 90 degree. So, we have already shown it is equal to 180 degree. So, I can say that an isosceles trapezium is always a cyclic one. Okay, I hope you have understood. We have made the construction of dropping the perpendiculars. Then we have taken the congruences of triangles and then we have just used parallel lines and a transversal in order to prove the concept of cyclic isosceles trapezium. Okay. ABC is an isosceles triangle with AB is equal to AC. If D and E are the midpoints of AB and AC, prove that BC, D and E are concyclic. Okay, so B, C, D and E are concyclic. So we need to prove that they are points on the circumference of a circle. Basically, they form a cyclic quadrilateral, right? So if there are 4 points which are on the same circle and if we join them, it becomes a cyclic quadrilateral, right? Okay, so we need to prove that the sum of the opposite angles is equal to 180 degree. So this angle plus this angle is 180 or this angle plus this angle is 180. Then we can say that BC, D and E are concyclic points. Okay, or we have learned the concept of concyclic points, which says that if you have 4 points and 2 points are over here, which forms a line segment, if they subtend the same angle on the same side of the chord, the 4 points are concyclic. Now, we will do the sum using both the methods. You can follow whichever method you want, whichever you feel comfortable with. So, let us start with the first one, which is using the concept of concyclic points, only concyclic points. I have drawn the diagram again. You know AB is equal to AC and D and E are the midpoints. So, this part is equal to this part and this part is equal to this part. Okay. Now, if B, C, D and E has to be proved to be concyclic, the angle subtended at D by BC and angle subtended at E by BC has to be equal. So, I will be joining them like this. Fine. I need to prove this angle and this angle are equal. Then I can say BC, D and E are concyclic. In order to do that, you know, I have to take the congruence of triangles. So, I will be taking the triangle BCD and triangle CBE. Okay, I know that BD is equal to CE. I got one side. I know BC is a common side. Okay, and I also know that angle B is equal to angle C because they are the base angles of the isosceles triangle ABC. So I can say that both the triangles are congruent by SAS congruence. Now because the triangles are congruent, I can say that this angle is equal to this angle by CBCT. So since they form the angles in the same segment for the chord BC, I can say that all the 4 points are concyclic. I hope you have understood the proof. AB and AC are two sides of an isosceles triangle which are equal. D and E are the midpoints. So this part has to be equal. I have formed two triangles because I needed to prove that this angle is equal to this angle, because if this is B and this is C, if I prove these two are equal, I can say that all the 4 points lie on the same circle. For that, I have taken the continuums of triangles where BC was a common side, BD and CE were already equal, and angle B is equal to angle C because they are the base angles of ABC. So I have proved it using the theorem on concyclic points. Now let us prove the same sum by using the theorem on cyclic quadrilaterals. So even if you forget, the theorem on concyclic points, because cyclic quadrilaterals, please do not forget, even if you forget the theorem on the concyclic points, you can apply the cyclic quadrilateral theorem and then move on with the sum. Okay, so now let us see how we can do it. Okay guys, so we know AB is equal to AC and D and E are the midpoints. So DE has to be parallel to AC. Okay, two lines are equal, the midpoints are joined, so the line has to be parallel to BC. Fine. What do we need to prove? In order to show BC, D and E are concyclic points, I need to show that the sum of the opposite angles is 180 degree. So I need to show either angle B plus angle E is 180 degree or angle C plus this part is 180 degree. Okay. Now BC is parallel to DE. This and this are corresponding angles. So I can say that angle B is equal to angle ADE. Using the property of parallel lines and transversal. Okay. Angle B is equal to angle C. We already know because they are the base angles of the isosceles triangle. So I can say angle C is equal to angle ADE. Okay. Now angle ADE plus this angle is equal to 180. They form a linear pair. So angle ADE plus angle BDE is equal to 180. Okay. But angle ADE is also already equal to angle C. So angle C plus angle BDE is equal to 180. This is angle C and this is angle BDE. So these two angles, the sum measures 180 degree. So they are supplementary, hence they form a cyclic quadrilateral, or the 4 points lie on the same circle or they are concyclic. So whichever method works easier for you, please adopt that method and follow with the sum and follow the sum. Please have a look at this question. P is a point on the side BC of triangle ABC such that AB is equal to AP. Through A and C, lines are drawn parallel to BC and AP so as to intersect D as shown. Show that ABCD is cyclic. So basically, the diagram is given to you and we need to prove that ABCD is cyclic. Okay. So A, B, C and D, we have to prove that they lie on the same circle. So it is given that AB is equal to AP. So I know angle B is equal to P over here. Okay. Now this will become 180 minus P. Okay. Through A and C, lines are drawn parallel to BC and PA. So there is a line which is parallel to BC. So AD is parallel to BC. And also line is drawn parallel to PA. This is parallel to this. Okay. Now we need to show that angle A plus angle C is equal to 180, or angle B plus angle D is equal to 180. Okay. Now you know that AD is parallel to PC and CD is parallel to AP. So both pairs are parallel. It becomes a parallelogram. the opposite angles of a parallelogram are equal. So I can say that this particular angle is equal to this particular angle. Same is applicable for here as well as here. Okay. Now I told you this angle is equal to this angle, and this becomes 180 minus angle BPA. Correct? So the sum of these two angles is 180. This angle is already equal to this, so I can say that angle D plus this angle is 180 degree. But angle APB is equal to angle B. So I will get angle D plus angle B is equal to 180. So the sum of the opposite angles is a 180 degree. I can say that ABCD is a cyclic quadrilateral. That's a very easy sum, though the diagram looked kind of a little bit confusing. But once you identify this as a parallelogram, the remaining part of the solution becomes very easy. ABCD is a cyclic quadrilateral whose diagonals AC and BD intersect at P. If AB is equal to DC, prove that so and so. Okay. So we have a cyclic quadrilateral ABCD. Okay. Now the diagonals are intersecting at the point P. And because it is a circle, it also has a center, and that center and the point P need not coincide. So I will mark the center over here. Let us call it as a point O. Now AB is equal to CD. So you need to prove that triangle PAB, this triangle and this triangle are congruent to each other. Okay. I have joined the vertices to the center O. So I have used a different colored pen for that. So let us start with the first part. Triangle PAB is congruent to triangle PDC. So this is my triangle PAB and this is PDC. So you know I have gotten one side. Okay. Now I can have either two more sides or have two more angles. So this angle and this angle are definitely equal because they form vertically opposite angles. So I got one angle. Now I need one more angle. So consider this chord BC, sorry. This particular angle, which is BDC and CAB, both are equal because they are angles in the same segment. I mean this angle and this angle. So I have got two angles for this triangle and one side. So I can say AAS congruence because these two angles are equal. This and this also has to be equal. So I can say by ASA congruence, both the triangles are equal to each other. Okay. Now the second part. PA is equal to PD and PC is equal to PP. I can say it's obvious because they are corresponding parts of congruent triangles. Now I need to show that AD is parallel to BC. This is AD and this is BC. Okay. In order to show they are parallel, so here you can see if AD and BC are equal, this and this form alternate interior angles, correct? Which means this angle and this angle. We have to prove they are equal. Fine. Now, look at the chord BC. We know that, no, I'm sorry, look at the chord AB. I know that ADB and ACB are equal to each other. The reason being they are angles in the same segment. So now I am talking about this angle and this angle. Okay. Now, we already proved PC is equal to PB, which makes this an isosceles triangle. Base angles are equal. So this angle is equal to this angle. So this and this are equal, thus making these two lines parallel. Okay. So though I marked the center in the beginning and connected the vertices to the center, I figured out that I don't really need to use any particular concept regarding the center. I only used the concept of equal chords make equal angles in the same, angles in the same segment of a circle are equal. Okay guys, we are at the end of the chapter and with cyclic quadrilaterals, we are winding up the chapter and there are so many sums in so many reference book. Try to do as much as possible. Don't try to do all the sums whichever you come across because it will actually confuse you and there are so many chapters to cover also. So do as much as you can so that you get the concept very clear inside your head. Now this particular chapter, there were a lot of theorems, some of them directly from the textbook. In addition to that, some of them we got it while doing the sums. So there were small points which we got while doing the sums, like the case of the centroid of an equilateral triangle, and then we learned how to draw an isosceles triangle inside a circle, how to place them. Such small things we have learned from doing certain sums. And when you are doing the sums like that and you are getting extra points, I would prefer that, it is always better you write it down in your own notebook so that you can go through them just before the exam, so that such bullet points will remain inside your head. That will really help you during the examination, because you may not be getting the same sum, but something very related, and you can immediately remember, oh, this is the concept that I have to apply. Along with this, I have to remember that also. So it makes it easier. And if you have any doubts in the contents of this video, mail me.